Hey there, me again. We are going to review multiplying, dividing, adding, subtracting rational expressions. So, because I feel like you may have forgotten, since we have 5 different methods, you may have forgotten what we did and how we got it done, that we would review real quick so you can finish this up. So, if you only have one fraction, notice there's only one fraction here. What are we going to have to do? First step is we're going to have to factor. You're going to factor the numerator and factor the denominator. So my factors here, when I factor this, 2k squared, first off I have a line leader other than 1, so I did look for a GCF. I don't have anything that will divide both 2, 1, and 15, so I factor 2 sets of parentheses. 2k squared factors into 2k and 1k, and I'm going to use, to get 15, I'm going to use 5 and 3. Okay, 5 times 1k is 5k, that's my innies. 2k times 3 is 6k. I need my big number up here to have this minus sign, so here's my minus sign. And I need the smaller number, 6k. I only want a 1k. I have a negative 6k, I only need a negative 1k. So that means I need a plus sign. So the first sign goes to the first parentheses, second sign goes to the second parentheses. Remember, this was just our little belly button math in order to help us kind of organize our thoughts when we had a leading coefficient other than 1. In our denominator, k squared minus 9, I have 2 sets of parentheses. K squared breaks down to k and k. 9 breaks down to 3 and 3. And to get a negative, need a positive and a negative. So we no longer have this part, no longer have this part. We are ready to mosey on to step 2. Step 2 is we are going to cancel like factors. And it's got to be 1 from the numerator and 1 from the denominator. So I have a 2k plus 5. There are no 2k's plus 5. I have a 1k minus 3 in the top. There's a 1k minus 3 in the bottom. And so I'm ready to write my answer. The answer is the remaining factors. So my answer is 2k plus 5 divided by k plus 3. Okay, moseying on to the next problem. This time I have 2 sets of, I've got 2 fractions, 2, and this sign in between is multiply. Make sure you pay attention to the sign in between. So if it's multiply, we have multiply. We're going to start off with the same way we did for simplify. Step 1 is we're going to factor, and factor everywhere we can factor. Okay, the first one n to the 5th. There's no plus or minus sign, so we can't factor that. In the bottom, I have n minus 6. Now, n's to the first power, all I could do is look for a GCF. There's no GCF between them, so I can't factor it. But over here, n is squared. So since this, I'm looking for either a GCF or difference of squares. Since my term on the right is not a perfect square, it's not a difference of squares. I'm going to have to look to see what do I have in common in both of these. And both of these happen to have an n. So n squared, if we take out an n, we only have an n left. Haven't done anything with my signs, haven't done anything with my numbers, so there's my 6. N, if I take out an n, I'm not going to have any n's left. So I can get rid of that. And in the denominator, I have n to the 8th. There's no plus or minus sign, so I can't cancel. Alright, speaking of cancel, we are ready to look to see if we can cancel. We're going to cancel like factors. You got to have one from the numerator and one from the denominator. So I have an n minus 6. I can take this one out, and I can take this one out. Now, if I look to see, hey, what do I have left over? I have an n to the 5th here, I have an n to the 1st there. That gives me n to the 6th power in the numerator. In the denominator, I have an n to the 8th power. Do you think any of those can cancel? Absolutely. N to the 6th means I have 6 n's. N to the 8th means I have 8 n's. So if they canceled each other out, if I wrote 1, 2, 3, 4, 5, 6 n's on top, and I write 1, 2, 3, 4, 5, 6, 7, 8 n's on the bottom, these would cancel, 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 and I think I missed one over here. And so what do I have left? I have 2 n's, or n squared in the denominator, and I can't leave it topless, so it's 1 over n squared. Okay, the next problem right below it. So multiplying, for multiplying, factor what you can, cancel like factors. Now we're ready to look at divide. Divide starts just like multiply. So when we have divide, we know it's divide, it's got that old-fashioned division sign in between. We're going to factor. I'm getting tired of writing factors, so I'm just going to put the F. Okay, so my numerator here, x is to the 1st power, so I can only look for a GCF, and there is no GCF here. 6 doesn't have a plus or minus sign, so you can't factor that. My numerator here, I can factor that one. My numerator, it's squared, so I'm looking for, and the y is squared, so I have a difference of squares. X squared breaks down to x and x. Y squared breaks down to y and y. And what signs do we multiply together to get a minus? Well, that would be a plus and a minus. So I no longer have that. Now, what makes a difference between divide and multiply? With divide, step 2 is we have to KCF. Keep, change, flip. So I'm going to keep my first fraction. I'm going to change division to multiplication. I'm going to flip that second fraction. So that's going to mean I have an x plus y divided by 6. Change division to multiplication. And in my second fraction, I'm going to flip this. 3 goes in the numerator, and I have x plus y times y, x minus y in the denominator. Okay, so now I'm ready to cancel like factors. So I have an x plus y in the numerator. Do we have an x plus y anywhere in the denominator? Yes. Yes, by George, we do. Okay, now anything else? We have a 3. It's not got a plus or minus sign next to it, so I'm looking for something with no plus or minus sign. And that looks like that's 6. 3 and the 6 will reduce. 3 goes into 3 1 time. 3 goes into 6 2 times. So my answer is 1 over 2 times x minus y. And here is our answer. Okay, the next one, we've got a quadruple decker sandwich. Does that problem not look cool? It is so cool looking. And what's best is that you can do this problem. You just need to know one little bitty secret. This quadruple decker sandwich is the same thing as if I had written 2 fractions with the old-fashioned division sign. So if I wrote this as 2 fractions with the old-fashioned division sign, all I'm going to do is take the first 2 make it a fraction, so x squared minus 4 over x squared minus 2x. Put the old-fashioned division sign, and then my bottom two go together. X plus 2 times x plus 2 over x squared plus 4x plus 4. Okay, now it's just a division problem like we just got through doing. So that means that now that you've rewritten it, you're going to factor, 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 factor. Step 2, keep change flip. Step 3, cancel like factors. And I'm asking the sub to please stop the computer for a minute so that students can go ahead and finish this problem up on their own. Please pause the video. Alrighty, welcome back. So we've factored x is squared, and this is a perfect square, so we have two sets of parentheses. X squared is x and x, 4 is 2 and 2, and to get a negative you're going to have 1 plus and 1 minus, so that's gone. Now in our denominator, x is squared, but 2x is not a perfect square, so that means we have to look for a GCF. What do we have in common in both of these? We have an x. So if you have an x squared and we take out an x, we still have an x left. Didn't do anything with our number, our sign, or our number, so there's my minus, there's my 2. If we have an x and we take out an x, will we have any x's left? No. So no more of that. In the numerator here, this is already factored. When it's written in parentheses, that means some awesome, amazing, nice person already factored it for you. And now for our denominator, x squared, we didn't have a GCF. X squared is x times x. 4 is 2 times 2. Put my biggest number first because my biggest number is going to get that first sign. I have a positive 2, I need a positive 4, so this is going to be also a positive 2. So, and cancel that. Okay, so we need to keep the first fraction. So that's going to be x plus 2 times x minus 2. And then x times x minus 2. We're going to change that division sign to multiplication, and we're flipping the second fraction. So we will have x plus 2 over x plus 2, or times x plus 2, sorry, all of that over x plus 2 times x plus 2. Man, there are a lot of 2's. Okay, and our last step, cancel what we can. The x plus 2 can cancel with an x plus 2. The x minus 2's can cancel each other out. The x plus 2 can cancel out with the x plus 2. And so we have an answer of x plus 2. And we know that this x and this x don't cancel each other out because this is in parentheses and this is not. This x is next to a plus sign. It cannot cancel with something, an x that is not next to a plus sign. So here is our final answer. Okay, last problem I'm going to work with you. We have an addition problem. And this addition problem, unfortunately, is not quite like the other addition problems we did before. On this particular addition problem, and what we're going to do tomorrow, is look at our denominators. Are they the same? No. But Shooty McShootsters, do you see this second denominator here? It's got a little squaredy guy. So we're going to try to factor him. We are going to factor him. X squared is going to factor into x and x. 25. Think of two numbers you can multiply together to get 25, and when you add